Welcome to Ganitavayani. I am HarshaVardhana. So, welcome from the previous session. In previous session, we had discussed about problems on the complex numbers. In today's session also, we have discussed some more problems on the complex numbers. That is, x plus 5 plus 3i whole cube in the form a plus ib. This problem can be solved in step-by-step method. That is, in step 1, we use the binomial expansion formula. The formula for the cube of binomial is a minus b whole cube is equal to a square minus 3a square b plus 3ab square minus b cube. Here in this, a is equal to 5 and b is equal to 3i. Substituting these values in the formula, we get 5 minus 3i whole cube is equal to 5 cube minus 3 5 square 3i plus 3 5i 3 square minus 3i cube. After this, we have in step 2 we have to calculate for the each term. We know that 5 cube is 125 and minus 3 5 square 3i is 1 minus 225i and 3 into 5 into 3i square is minus 135 and minus 3i whole cube is 27i. In step 3, we combine the terms. In this, we add the results from step 2. We get 125 minus 225i minus 135 plus 27i. In step 4, we simplify to a plus bi form. In this, we combine first real part, that is 125 minus 135 is minus 10, and in imaginary parts minus 225 plus 27i is minus 198i. Therefore, the final expression is minus 10 minus 198i. Then here the conjugate of modulus of a complex number. The conjugate of a complex number is another complex number with the same real part but opposite sign for the imaginary part. For a complex number z is equal to a plus b, conjugate is z bar, that is equal to a minus bi. Then we find a definition that to find the conjugate, simply change the imaginary part of a complex number. If the complex number of 3 plus 2i is 3 minus 2i and conjugate of 5 minus 4i is 5 plus 4i. Welcome from the previous slide. Now we are going to see the properties of conjugate numbers. That is, if z1, z2, z are the complex numbers, then z bar bar is z and z plus z bar is 2 real part of z. Z minus z bar is 2i imaginary part of imaginary part. Z is equal to Z bar is equal to Z is purely real. Fifth, Z plus Z bar is equal to 0. Z is purely imaginary. Z bar is real part of Z whole square plus imaginary part of Z whole square. Z1 plus Z2 bar is equal to Z1 bar plus Z2 bar. Z1 minus Z2 bar is equal to Z1 bar minus Z2 bar. Z1 Z2 bar is equal to Z1 bar Z2 bar. Z1 by Z2 bar is equal to Z1 bar by Z2 bar, where Z2 is not equal to 0. Then modulus of a complex number. The modulus of a complex number Z is equal to A plus Bi is the distance from the origin to the point A comma B in the complex plane. Calculated using the formula mod Z is equal to root of A square plus B square. It is the non-negative square root of the sum of the squares, and the real part is A and the imaginary part is B. And after this we have to identify the real and imaginary parts. For A complex number Z is equal to A plus Bi, the real part is A and the imaginary part is B. After this we square both parts. Calculate A square plus B square. After that add the squares. Find the sum of the squares values, that is A square plus B square. And after that take the square root. The modulus of the square root of the sum is mod Z, that is equal to root of A square plus B square. With this I will conclude this session. If you have any doubt or clarification in this video or in previous videos or any other videos regarding to this chapter, you put comment in the comment box. I will rectify the same, and if you didn't see the video, I will put the link in the description box. You can click on the link and see the video. And one more thing, that if you like the videos, please subscribe the link. Thereby I will get the encouragement for doing the same in further videos. And in the comment box you can have you can give me any suggestions regarding to this video, so that I can improve my videos in the next class or another in further videos itself.